Well, let's solve some polynomial equations. Here's an example of a polynomial equation. And our job is to figure out the numbers that make it true. You could probably guess and check through these, but it's not obvious. And I mean, I've been doing this for a long time, and I can't just look at this necessarily and in 2 seconds flat come up with what those answers are. But if I give you the same expression on the left in factored form, it looks like this. And now the answers reveal themselves quite easily. Well, why? Well, there's a notion in our number system that says if you multiply two numbers, A and B, and you get 0 for an answer, then A is 0. Or, if not, B is 0. Or they could both be 0. But so, for example, if you know that you multiplied to get an answer of 0, this can't be 5 times 7. This can't be 3 times 4. There has to be a 0 as one of these factors. Or another way of saying that is, if you know that A is 6, and that this product is 0, so 6 times B is 0, then that B has to be 0. That's what makes solving this equation so easy. Okay, so think of this as the A, and think of this as the B. One of these things has to be 0. And so you just take these one at a time. And you say, I think B is 0, maybe. Well, if B is 0, you can ignore A for a minute and just cover this up. Okay, x minus 3 then has to be 0. That doesn't mean that x is 0. It means that x is 3. Because 3 minus 3 makes 0. And you just found one of the answers. These answers have different names. Sometimes they're just called answers, but more often than not, they're called roots. They're also called zeros because they help the calculation come out to 0. So that 3 is a solution, an answer, a root, and a 0. It's all 4 of those things. And when you have 2 different factors like this, there's another answer. You cover up the second one and take the case where maybe 0 is the answer over here because A is 0, not x, but this whole factor is equal to 0. Well, then it must be because x is 2, because 2 minus 2 is 0. So now you have your other answer. Now you have your other answer. Okay, we're going to go through today and solve a bunch of these problems. And they all kind of look like that. And the first one, let's cover up these so they're not distracting. The first one says solve y plus 2 times y minus 6 equals 0. All right. Well, I'm going to hide this one first and just concentrate on y plus 2 equals 0. Okay, we might have 0 here because this is negative 2 plus 2. So one of the answers that solves this polynomial equation is negative 2. Now I'm going to cover up y plus 2, and I'm going to think about this little subtraction. How could this be equal to 0? Well, if it's 6 minus 6. So there's your other answer. There's your other root. There's your other solution. So you can come over here and you can write y equals negative 2 or y equals 6 because they both work. Let's solve another one here. Let's go a little faster this time. Cover this factor up. This must be 1 minus 1. So the answer I get here is a 1. So one of our solutions is s equals 1. What's the other one? Well, cover up this factor. S minus 9 equals 0. That has to be 9 minus 9, doesn't it? So that S value is 9. So you get 9 or 1. As you can see, once you've done 2 or 3 of these, they start to get pretty easy. Now, this could be making the 0 over here because you have a negative 7 where that x is. Negative 7 plus 7 is 0. And so you'd have 0 here times negative 7 there, and you get 0 for an answer. So there's one of your answers. X is negative 7. But it could also be the case that the other factor is 0. So this basically tells you what the answer is. The other answer is x equals 0. So we have two answers. We have two roots. We have two solutions. They are negative 7 and 0. Okay. This problem is very similar to the last one. You get one of your answers out of the t minus 5 factor, and of course that would be 5 minus 5. So t equals 5 is one of the answers. To get the other answer, you need to cover up the t minus 5. Let's see if this does a better job. Yes, we have a stopper for a coffee cup. And now I have 12t equals 0. Okay, if you want to solve that by dividing by 12, you can do that. Divide both sides by 12, and you end up with 0 divided by 12 is 0, so t equals 0. Or you could just ask yourself 12 times what is 0? It's got to be 0. Okay, now these get a little more complicated because not every student I know could just look at the problem and decide what the answer is. But if you just cover up one factor at a time, and then if necessary, go solve the remaining equation. This is 2a minus 6 equals 0. Some students can just look at this and tell there has to be a 3 here. A is 3 because 2 times 3 is 6 and 6 minus 6 is 0. But if you're not that student, so what? You can still solve this, can't you? Yeah, just add 6 to both sides. You get 2a equals 6, and you divide both sides by 2, and you get a equals 3. So one of the solutions is a equals 3, or the other solution is what you get when you solve 3a plus 15 equals 0. So you're going to subtract 15 from both sides. You're going to get 3a equals negative 15. And you're going to divide both sides by 3. So divide by 3, you're going to get a equals negative 5 as your other solution, your other root, your other 0. Well, let's do one more like that where we actually have to solve some equations. The equations that you're going to solve are, okay, remember the theory behind it. Either this factor is 0 or this factor is 0. So you consider them one at a time. Solve 2 minus 4d equals 0. And do that by subtracting 2. So negative 4d equals negative 2. Now divide both sides by negative 4. Encroaching on the space of the next problem. That's okay, it's an easy one. Negative 2 divided by negative 4, your calculator will tell you that that's equal to 0.5 or 1/2. So 0.5 or 1/2 is one of the answers. And then the other answer comes from solving this equation. And it's solved similarly, except you have a plus sign here. And I'll just tell you, it's going to end up being negative 0.5 or negative 1/2. Okay, now for an easy problem, we have h minus 8 squared equals 0. I probably don't need to tell you that that's the same as h minus 8 times h minus 8. Well, if these two factors are exactly the same, you shouldn't expect two different answers. The number that causes the first factor to be 0 is 8. 8 minus 8 is 0. So here's our first answer. But the other factor is exactly the same. And so the root, the solution, the 0 that solves this is 8. And that's nothing different than you had before. So duplicate factors lead to not as many roots. In this case, you just get one root. Here's a problem that has 3 answers, I think. I haven't solved this one yet, but let's take a look. there are 3 factors, so you have the potential for 3 answers. So let's cover up the first 2 factors and just look down here. How do you solve negative c plus 6 equals 0? I would add c to both sides. That's the way I'd do it. And I'd get 6 equals c. 6 equals c is one of our answers. And then how would you solve 5c plus 5 equals 0? Well, you're probably going to have to subtract 5 from both sides, like this. And then you're going to have to divide both sides by 5, like this. And you're going to get c equals negative 1. 3 factors sometimes has 3 answers. Let's see if we get a different answer from this third factor over here. Solving 15 minus 5c equals 0 can lead to a third answer. 15 minus 5c equals 0. So subtract 15 from both sides. And then divide by negative 5. And you're going to have an answer of c equals 3. Look at that. 3 different factors, 3 different answers. Now, of course, factoring is great. A factored polynomial equal to 0 is a pretty easy thing to solve, especially in some cases like the ones we saw back here, where we didn't really have to solve any equations. We just had to cover up and think about, oh yeah, 6 minus 6 is 0, or negative 2 plus 2 is 0. And we get those solutions just by observing. Well, there's another style of problem where the answers are also quite easy to get. And in this style, they give you both a factored polynomial and they give you a graph. And the graph doesn't look like a line, that this is a curve. So when they ask you to find the roots, they're asking you to solve this equation. X plus 1 times x plus 7 equals 0. Now, what we've been doing has been working just fine. We cover one of the factors up, and we ask ourselves, what number would go here to make 0 there? Well, it's negative 7. And then, what number would go here to make 0 over there? Well, it's negative 1. So these are our roots. They're also called zeros, or solutions, or answers. But you know what? We could have got them right off the graph, because negative 1 is right here between 0 and negative 2, and negative 7 is right over here between negative 6 and negative 8. So there's a connection between these roots and the point where the curve crosses the x-axis. So it's kind of hard for me to write this over here, but there's these 2 points. And if you went and looked at the numbers there, they would look like negative 7, 0, and negative 1, 0. Those are called X-intercepts, and they reveal the roots. So let's try this one. Let's see if we can do this one, both ways. Okay, to me the easy way is you set it equal to 0, and you cover up the factors. Okay, that's pretty clearly 5 minus 5, isn't it? So one of the roots is 5. But what's the other root? Well, you cover up this factor and you have x minus 14 equals 0. So the other root has to be 14. Now, remember, you can get these off the graph sometimes. To me, this graph's not very good because it only has numbers like 0 and 8 and 16 on it. All right? So this one, you're going to go like this. You're going to read the number here, which is 1, and one of your factors is x minus 1. Now you read the number over here, and it's negative 4. So the other factor has to be x plus 4. But why is it plus? Because we need this factor to equal 0 when we plug that number in. Because quite literally, the ordered pair on the x-intercept there is negative 4 and 0. And negative 4 plus 4 makes 0. So we're using these two intercepts to help us figure out what these factors were. This is not quite right. I think you're also going to need to multiply by some negative number here. And let's just say we're not sure what it is, so we'll call it A. But otherwise, we'd never get an inverted parabola like that. And don't worry about finding the A. That's a future topic. Okay, we're almost done. We have one more problem. Write the equation for this curve. And the equation for this curve, as best I know, will have 3 factors in it because there are 3 x-intercepts. There's one here at 2, so you'd have a factor of x minus 2. There's one here at negative 1, so you'd have a factor of x plus 1. And then there's a factor over here at negative 4, or excuse me, an x-intercept at negative 4, and that tells me we would have a factor of x plus 4. And then you would possibly have to multiply all this by some number a, which could be positive or negative. But that's about the only thing we can't figure out yet. So this would be the factored form of the polynomial that made that graph. Well, that's about it for the day. Hope you enjoyed. My name's Eric. Have a good day.